Hello, everyone. So today, let's understand the basic differences between a turbojet and a turbofan engine. So this video will help you to understand which kind of engine is used in which aircraft, what are the various advantages and disadvantages of one engine over the other. And this is more of an introduction of basic differences between the two engines. We are not going to enter into much of the technical equations, but still we will be able to understand how the engine operates and what are the major differences. So before starting with the differences, let's first understand what is the major layout of the two engines. So both turbojet and turbofan engines basically belongs to one family, which is gas turbine engine family. All right. The another family of engines is basically the reciprocating engines. We are not focusing on that today. So gas turbine engine family typically operates on a thermodynamic cycle, which is known as Brayton cycle. All right. So both of these engines operate on same thermodynamic cycle, which is Brayton cycle. As I told you, I'm not going to enter into much of the technical terms here. Let's understand what is the major difference between these two. So in turbojet engine, if you see the component specifications or the components are very easy and easy to understand also. So air enters in this particular direction at the front of the engine. The first component which we see is the diffuser. All right. Then from the diffuser, the air enters into the compressor. Now each component is having a specific function. All right. So this require a detailed lecture. Let's understand the basic terminologies first. So you have a compressor. Then after the compressor, air enters into what is known as burners or combustion chamber, in which we typically burn fuel. You can see the burning happening here. Then this burned air enter into turbine, all right, this portion, which is basically producing work for your engine. And then these hot gases comes out from the nozzle. Now the nozzle can be a CD nozzle or it can be a direct um, converging nozzle. So this is a basic layout which looks very simple, right? When it comes to turbofan engines, there's a slight variation. So before entering into this portion of diffuser, what you do is you install a fan. You can see a big fan at the entry, right? If you see this fan. In turbojet, this fan is not present. Now, what this fan does is it divides your air into two streams. One, if you see this portion, is basically a cold stream, and the other amount of air enters inside, which is known as the core engine. Now this core engine is very much similar to turbojet. So what basically you have done is you have taken a turbojet engine and ahead of it you have installed a fan, a big fan, which is also known as a low pressure compressor. Now inside this hot engine, if you see inside this core engine, you will again see compressors, you will again see combustion chamber, you will again see certain turbines, and then you will see a nozzle. So it looks very much similar to turbojet. The only difference between turbojet and turbofan is this bypass duct, in which actually cold air is flying or passing through. And this is where the major difference between the two engine lies. So, as a layman person, if you're not interested, if you're not into particularly aerospace domain or specifically in propulsion, and if you want to look into an engine from a naked eye, the first major difference which I'll say is you will not see these big fans in turbojet engine, but if you see these big fan blades inside the engine cover, then it is a turbofan engine. So just seeing the aircraft and seeing the engine, you can tell which engine is being used. I'm not going into turboprop, in which you install big propeller blades outside the cowling. So this that is turboprop engine. So let's not go into that. Now, keeping this in mind, I've just summarized what I have just said. So you have a diffuser, compressor, combustion chamber, turbine, and a nozzle in turbojet engines. When it comes to turbofan, you have first a big fan which will divide the air. Some portion of the air go into the bypass duct, which we also known as cold nozzle, which you can see this outside portion, this portion. And then the remaining air entering into core engine, in which you will have again the compressor, combustion chamber, turbine, and nozzle. Now, I'm not going into what is this high pressure, low pressure turbine, because this is going into more technicalities and complicate the video. All right. So, seeing this itself, we can answer few things or understand the differences. So, if you see, turbojet engine was very simple, correct? So it has lower frontal area. The reason being you have not kept a big fan at the starting of it. You can see this from the schematic diagram itself. You have to keep a fan, so the frontal area for turbofan engine is big. Correct? So turbofan engines has large frontal areas, whereas turbojet engines has lower frontal areas. One major difference. Visualization, you can see this. Second, because you have less complicated parts, turbojet engines are basically cheaper and it is very easy for maintenance. Whereas turbo fan engines are costlier. You need to make big fan blades, big arrangements, bigger engines, and hence it require high maintenance also. And this is the reason your turbojet engines are lower in weight and your turbofan engines are higher in weight. Now, keeping these points in mind, you can understand few things. Because there is low frontal area, there will be low drag. And if it is low drag, that means you can travel faster. So turbojet engines basically used when you want to travel very fast. Basically fighter aircrafts when you want to travel at a Mach number of 2, 3 and higher. Turbofan engines, because of their larger frontal area, has more drag, and more drag means you cannot travel at very, very high speeds. So you will see its application both in fighter aircrafts, typically if you want to fly till Mach number 2, and most commonly engine which you have seen throughout your life when you go to airport, when you see any engine, right? Mostly 99.9% of the times you will see what is a turbofan engine because it can be used at a low Mach numbers also. At typically Mach numbers of zero point 0.6 to 2, it has a beautiful specific fuel consumption as an economy as well. Now, another major difference between turbojet and turbofan engine is the takeoff run. The problem with turbojet engines is that it needs high velocities at the entry, high velocity of air at the entry before it can take off. Whereas in turbofan engines, because fan is the one who is also helping you to produce some amount of what is known as cold thrust, you need shorter takeoff runs. This is one of the reason even in fighter aircrafts you see what is known as low bypass ratio turbofan engines. Keep one thing in mind: when you are having a fighter aircraft, you need to take off from a very shorter distances as well. I have taken an example taking off from an aircraft carrier. Carrier is limited in length, right? So you need shorter takeoff runs. Let's say during some any emergency thing or something, you land in an enemy territory, then you again need shorter runways, right? You cannot expect to have very long runways for takeoffs. So turbofan engines are also very, very commonly used in fighter aircraft because of this advantage. Next advantage is they are very, I should not say very, they are relatively quieter engine compared to turbojet. And see the applications, fighter aircrafts, because they can travel fast, they can go to high altitudes. That's the major advantage, very lightweight. Whereas compared to turbofan, which needs shorter takeoff runs, this is the reason it can use for fighter as well as for commercial aircrafts. They are better for low speeds as well. So it's like depending upon the application, you should tell whether I should use a turbojet engine or whether I should use for turbofan engine. The important point to keep in mind is whatever commercial flights you're seeing in airport, it is basically turbofan, or if you see big propeller blades, then it is turboprop. You will never going to see a turbojet engine in your regular flights when you go to the airport. Now, just to wrap up, you can see it's when you talk about Turbojet, because of its simple design, you can even use afterburners. Very easy to install. You can produce high thrust, run from enemies, do many maneuvers. Whenever you need high thrust, you can use them. Because turbofan engine is already a difficult engine, so it is slightly difficult or more expensive, or it makes your design more complicated. So difficult to employ afterburners. All right. Turbojet engines, fuel consumption is higher at lower speeds because it is designed to travel at high speeds, and it is designed to travel at high altitude. So if you travel at low speeds, it doesn't mean you cannot travel. You can, but your fuel consumption will be very high. You should move to high altitudes only as early as possible. Whereas turbofan engine is good. Its SFC is lower at lower speeds and altitudes. Everything what I'm saying is relative to turbojet. Compared to turboprop, both these engines are bad in certain regimes. And because of these reasons, it is not good money wise. You can see the designed Mach numbers at which turbojet engine should fly is between Mach numbers 2 to 2.5. Whereas when it comes to turbofan engines, it can fly even at lower speeds and at high speeds. The reason being, you can control your fan, and depending upon that fan, whether it is low bypass or high bypass, you can use it for various applications. So, guys, keep one thing in mind as a basic difference. Turbofan engines are more customized engines. Turbofan engines is basically an engine which is sitting exactly between turbojet and turboprop. So turbojet engine is one which flies very fast. Turboprop engine is one which flies very slow. And turbofan sits in between these two. It's basically a combination of both. It is using some advantages of turboprop to fly at a lower Mach numbers, and it is using some advantages of turbojet engine to fly at a very high Mach numbers. And in the process, it becomes a complicated design. All right, so it's very difficult, costlier to the company, very high maintenance required, and definitely heavy. All right, so very basic difference. Hope you found this lecture a bit interesting. And for more detailed difference between turbojet and turbofan, we have a very detailed equations and all the governing parameters. You can find this in the propulsion lecture series. All right. Thank you so much, guys. Hopefully, this lecture is meaningful and it helps you in understanding the major differences. Thank you so much. Bye bye.